Hello, this is Josh Carpenter from Team 28 for the project Proximity Sensing in a Post-COVID World. We just finished Sprint 2, and we had a pretty good sprint. Here's our Taiga board. Our team is divided into kind of a front end, back end. So three of the guys, Russell, Kelly, and Dylan, are focusing on the back end. Russell, most of the sprint worked on was getting some data generation for a lot of the other gestures. Kelly worked on a lot of the continuing work on the model, the model for processing the data and training the model within our machine learning algorithms for the gesture interpretation. And then Dylan is worked on the getting the output data from the new sensor that we worked with our sponsor on, getting a new sensor configuration, and he's working on those configurations and getting the output data there. Michael and I have been working on the front end, and that's kind of what we're going to primarily showcase today. You can also see here's our master branch. Everything's updated up to the end of our Sprint 2 here. Kelly also went through and reorganized this, so it's going to look a little different than our last artifact video due to that. So it was starting to get a little messy, so it is now reorganized and just a much cleaner look and easier to find things. So we are going to dive into the Python ATM, the front end that Michael and I have been working on. So at the end of 401, we had gotten an ATM interface completed, but it was not really ready for gestures. It was more about getting the, just kind of the entry point into getting an ATM interface designed. And that initially just used the buttons on the screen. So what we wanted to do now is start to refactor this and get it ready for gesture entry, right? So some of this is the same as it was previously in our V1, our version 1 of the interface. There are some variables added at the top that relate specifically to gesture navigation within the interface. You can see here that we've added a keyboard listener, and essentially what the keyboard listener is it is a placeholder for the gesture listener. So the logic should all be fine and should be able to remain in place. Once we're ready to connect with the back end, we'll be replacing this keyboard listener that we've implemented with the listener that will read the data from the sensors and from our machine learning models from the back end. So here's just the GUI setup of the display. A lot of this is the same, and you'll see here in a second when I execute the program. A lot of this is the same. It's going to look the same. However, most of the buttons are disabled. We did leave some functionality for the clear and cancel buttons. It's kind of a fail-safe in case, for whatever reason, once we do connect with the back end, if a gesture is not reading correctly, you don't have to terminate the entire program to start over. We can just, we can click cancel to start over and clear the pin code. So just a couple buttons still remain enabled for fail-safe reasons, and at some point we may refactor the actual look and feel of the interface, but for now it looks the same. So you can see at the bottom here we are initializing the key listener and starting that process there. The first method you'll see, called navigation gestures, actually takes the key as input, as a parameter to that method. This is really the backbone of the program. This is where we use our Boolean gates that we are flipping on and off as we navigate through the various screens, so that we know what screen we're on. Because based on what screen we're on, we want our keyboard or gesture to do something different, right? So a left swipe needs to do something different on one screen versus another. So, so the logic, like I said previously, will remain in place, but the keyboard listener will at some point be replaced with the gesture listener or the gesture input. So this is kind of the backbone. So you can see, like, if you're on a specific screen, do this for enter. If you're on this screen, do this for right, for left. So this is kind of the backbone of how we're navigating the program. And if you scroll through that, then we have the pin iterator, which is you'll see shortly. It kind of simulates a carousel for how to enter the pin via gestures. And a lot of the rest of it, the rest of it is the display, the methods for displaying the various screens and flipping those Boolean gates, as you can see. We did have to refactor a lot of this because now we are displaying the information with the fact that they're entering input from gestures versus hitting buttons on the panel. So while the look and feel is similar, the menus are very different. So let's go ahead and run the program. And let me terminate it and start it over here. Whoops. Okay. So you can see, welcome to the ASU ATM system. Hover to begin. I believe they used to say enter PIN to continue. So the hover for now is simulated with the enter button. So when I hover, I'm going to be hitting enter, and then left and right arrows simulates a left swipe and a right swipe. And those are the three gestures we're working on initially. That may be expanded at a later point, but right now we're focusing on left swipe, right swipe, and hover. So I'm going to go ahead and hit enter, and now we've begun. This is our PIN entry screen. And you can see it kind of simulates a carousel. So I'm hitting right arrow right now. And then I can hit left arrow. You can see it's just cycling through the numbers. So the default PIN is 1, 2, 3, 4. So I'm going to hit enter, which would simulate a hover to input a number. And then I'm going to hit 2, go right, and then hit enter for 3 to hover for 3, and then 4. And now you can see run our main menu. And you can see I can swipe left or right to cycle through the menu options. We'll go ahead and check the balance, and you can see we have $280 in the bank. And I'll swipe left or hit left arrow key for now to go back. We'll go ahead and withdraw funds. So if we try to withdraw $300, I'm just right swiping. You can left swipe to decrease the amount you want to take out. So if we try to take out $300, you can see we have insufficient funds. So I'm going to swipe back. Why do we have insufficient funds? Check our balance. Oh, we only have $280. So we're going to just withdraw $100, $120. And we take our cash. Do we want another transaction? If we want to, yes, we want another transaction. We can hit yes. And we can deposit funds. Do you want to deposit cash or check? Cash. We'll deposit $20. Deposit was successful. Would you like another transaction? We will say no. And now we're back to the beginning. But I know I told you a couple buttons were implemented for fail-safes. So the cancel button's implemented. So if I get in here and for some reason gestures aren't working and I'm in deep like here, I can hit cancel and it just resets the entire program back to the beginning. And then the same for clear is also kind of a fail-safe. So if I enter the wrong PIN, and this will all be, at some point we'd like to refactor it and get it actually incorporated into the gestures so that this is all user-friendly, but I keep using the word fail-safe because that's really what it is right now. So I can clear the PIN here. And that clear button only works here. It's just to clear the PIN so you don't have to terminate and cancel the entire program and go back to the hover menu. So that's kind of where we're at. Yeah, thanks.